This example comes out of section 9.1. So in this example we're asked to graph this function y equals 3x minus 2 divided by x minus 5, and we're asked to identify asymptotes and intercepts. Intercepts you might be able to do right away, because to find the x-intercept you let y equals 0 and solve. To find the y-intercept you let x equals 0 and solve. So we will do that. The asymptotes are a little bit trickier here. We suspect that at x equals 5 we're going to have something going on, possibly a vertical asymptote, and in this case it actually does turn out to be that. You can obviously punch this into your calculator and get some sense of what it looks like, and if you do that you get a drawing that looks something like this: 1, 2, 3, 4, 5, and that is where the vertical asymptote is located. And then somewhere up here you also have a horizontal asymptote, and you have a curve kind of in this region and in this region, roughly like that. And again, that's just off the screen of your calculator, so you can't necessarily get all the details you'd want here. But when it comes to the vertical asymptote, it is at x equals 5. Now the horizontal asymptote, there's a few different ways of finding it. For those of you that go on to calculus, the easiest way to find this is actually to look at it as what happens as huge numbers go in for x. In other words, as x goes towards infinity in this expression, 3x minus 2 over x minus 5. So put in gigantic numbers, 1 million, 100 million, 100 billion for x, and what you'll see is you basically have 3 over 1. You have answers getting closer and closer to 3, whether you put in huge positive or huge negative numbers. And it turns out that that is the value of the horizontal asymptote. Another way to do this would be to say, well, what if you divided 3x minus 2 divided by x minus 5? Well, the answer would be 3. We'd have 3x minus 15. We'd subtract, we'd get a remainder of 13. If we wrote the division statement, we could say that this 3x minus 2 over x minus 5, which was our original function, is actually equal to 3 plus 13 over x minus 5. Written that way, this function you could do as we did a previous example where you just said, okay, think of it as transformations of the original y equals 1 over x function. Your book does something interesting that I actually had never seen before looking at this book, which says that if y equals 3x minus 2 over x minus 5, let's go on the top here and artificially create something where we have an x minus 5 term that we can cancel out. And what you'll notice is that, so you've got 3x minus 5 over x minus 5 plus 13 over x minus 5, and you do actually end up with what we got by doing the long division method, which I personally think the long division method is easier. This is almost in some ways like completing the square. Now there's no square here, but we had to artificially put this minus 15 plus 15 term in this step over here that got us to be able to do this. Any way you look at it, the horizontal asymptote is y equals 3. I personally would either do this or just think of great big numbers in for x and see what it approaches. And if it's a nice number like 3, it won't be too hard to find. Now for the intercepts, for y-intercept, let x equals 0. Well, that shouldn't be too hard. Y equals 0 minus 2 over 0 minus 5, which equals 2 over 5. So your y-intercept is 2 over 5, 0.4, very close to the origin. For your x-intercept, let y equal 0. Now that one a lot of people have more trouble with, even though it really shouldn't be any worse. Fact is that we've already determined that x can't equal 5 way up here when we talked about the vertical asymptote. That's our non-permissible value right from the start. And so we don't need to really worry about x being equal to 5. So at this point we can multiply both sides of this equation by x minus 5, and we have 0 equals 3x minus 2. The only thing that's going to make this expression 0 is if the numerator is 0, which means that x equals 2 divided by 3. And so that x-intercept is that x equals 2/3. So you have your asymptotes, you have your intercepts, and you've got your question B.